Data, plural form of datum, means in Latin about something given, which means it's about information that given. In modern days, data has significant importance to humanity. It helps us in economics, scientifics, politics, and etc. But how we understand about a data? In this video, we will discuss about how we measure or how we interpret a data. So let's check it out. If you remember in my previous video, we have this integral, which M capital here is about this integral. Then this integral in white we called as central mass position, which means central distribution of rigid body mass, or at least a body mass. Here we see that rho that depend on x or position is about distribution of mass at some position inside the region of omega. Meanwhile, the M capital is about total mass inside region omega. So, these both and the integral itself, it seems like it told us about average position. I mean, look at this. Each partition of mass inside region omega has distribution rho with respect to x as position. So here, each object has information about its position. So by this thing, we can move to the concept of average, mean, or expectation value in statistics. And fun fact, in rigid body mechanics, this concept helps us in Euler's law of motion that we only care about average position so we can define kinematics and dynamics about the objects. But why we do care about this? If you ask why, I just tell you in the opening of video, so in the next section, we will learn one by one about basics data interpretation. The first one is expectation value. This value denotes as this for measurement, let's say A, then this expectation value inside region omega is about this integral, which x here is about each data inside the region omega, and A as measurement depend on x. And I almost forgot that M capital here, analogous to before, is about this integral as some kind of normalization. So this all integral is a basics, especially most basics in statistics. In this integral, A is what measure or measurement that has quantity, maybe vector, maybe tensor, maybe matrix, and etc. Px is distribution of x in the region omega that affect on measurement A. Measurement A depend on x, so by the before integral, we see some kind of expected value of A denoted as below, which means average quantity of A. Next, we move to variance, which is expected value of square deviation from mean, or expected value of the measurement. This variance defined as sigma A, which variance for A measurement equals to 1 over M capital, then integral, which inside is about this, and here we measure the expectation A itself minus its average in before, which here expectation value of A denote as mu. After that, we can denote this integral as this, and you see that this integration only effect on M, so it not effect on mu and mu squared here. Then in the next, we can rewrite as this long term, so in the integral middle here is about expectation value mu, and here is about M capital, and the last one here is about expectation value for A squared. And after some modification, we can simplify the old term before as this, which in this notation has final result as this. This final result will have important contribution maybe in next future videos. Alright, before we say goodbye, I will make some example about Px function known as distribution. This distribution can relate about distribution of mass, distribution of charge, distribution of probability in probability theory, and etc. All of this can be discrete or continuous, which if it's discrete, instead we use integration, we can use summation sigma. and some addition that may useful in the next video. In distribution of probability, the all probability inside our old system, omega, is equals to 1, which this definition comes from probability theory, and this one means that all total probability it must happen 100%. So in probability, you may think about 20% it happen. It means that possibility of it happen only 20 over 100. So if 100 over 100 may happen, it means that it must happen, or all things or all combination of state that may happen, I mean in entropy and statistical mechanics, 100% may happen at all. That's the concept that we will use in the next video. Okay, so that's about the basic statistic that we will use in physics. I hope you enjoyed this video. If you like this video, please share this video and click the subscribe button below. If you have any question, please share comments below, and that's it. See you later.